Okay, we'll go ahead and get started. Anybody have any questions over the syllabus, where to find anything? Anybody happen to try and look at the video that I did the other day? Did it come out okay? Yes? Okay. So no problems with that? I had a couple other students in one of my other classes couldn't find them. So they're right there when you go into Canvas. You click right on it. And okay. All right, so we have some questions over homework. I gave you quite a few problems to work through. What did you have there? What number? 45? Okay. Ah, good, yes. All right, so we have 2 over 5, or 2/5, A, equals -4. All right, now, last class, we talked about whenever you have a number in front of your variable, see our variable here is A, that we normally come through and divide both sides by that number in order to eliminate the number to get a 1 there. The problem is what's in front of it here is not a nice integer, it's a fraction, and we don't like fractions, right? So you have two options, all right? There are two options, and then maybe as a class we can decide which one we like more. Okay, one option is to divide both sides by that number, whatever it is, 2/5, right? So if I choose to divide by 2/5, then what I'm going to get is this. I'll have my 2/5 A equals -4. Now I'm going to divide both sides by 2/5. Now on the left side, anything divided by itself should be 1, right? So we should just get these two to just cancel out and become a 1, and that will leave us with an A on the left side. No problem, I think, right? It's the one on the right that causes the trouble. And it's very natural. If you're confused by that, I mean, join the club. A lot of people are. So let me explain to you what this -4 over 2/5 means. What it means is -4 over 1 divided by 2/5. Remember that any number over itself, any number can be written as itself over 1. So you can rewrite -4 as -4 divided by 1. And now what you have is what's called a complex fraction. You have a fraction over a fraction. So how do we divide two fractions like this? Anyone remember how to divide two fractions? That's if you were going to add two fractions, you would get common. Flip it. Okay, now what do you mean flip it? So here's really what's happening. What you're doing is you're taking the -4 over 1 and you're dividing it by 2/5, right? That's another way of writing that. And division, if you remember way back when you were taught multiplication, division of fractions, you were taught that division of fractions is equivalent to multiplication of the reciprocal. So we can convert that division symbol into a multiplication symbol if we flip the second fraction over, what we're dividing by, and make it a 5 over 2. And so with multiplication, now we just go straight across. So what is -4 times 5? -20, right? And then what is 1 times 2? 2. And what's -20 divided by 2? -10. So the left side becomes -10. Right side becomes -10. That's one way of doing it, but that's not the way that I think a lot of students do it. They do it the second option. Question? No? Yeah? Okay. So this is option 1. You actually divide by the fraction, then you flip it, but you also have to realize that -4 is -4 over 1, so on and so forth. So that's your first way. Here's another approach. Okay, same exact problem. We'll take our 2/5 A equals -4, and instead of dividing by 2/5, because it's a fraction, and only because it's a fraction, I'm going to instead divide by 2/5, I'm going to multiply both sides by its reciprocal. So whatever I see there, 2 over 5, I multiply both sides by that flipped. So I will step in and multiply the left side by 5 over 2, multiplication with the dot. And whatever I do on the left side, I must do on the right side, so 5 over 2 on the right. If you do it this way, Then look what happens on the left. If you multiply straight across, what's 5 times 2? 10, and what's 2 times 5 on the bottom? 10. 10 over 10 is 1. Or you could say the 5's cancel and the 2's cancel, and that all just gives you a 1 over there. Now, on the right side, we still have to multiply negative 4 times 5 halves. But again, you can write that negative 4 as what? Negative 4 over 1, and then multiply straight across again. So negative 4 times 5 is negative 20. 1 times 2 gives you 2. So you multiply here, negative 20 over 2, and that gave us negative 10 again. Do y'all follow that? So this is the way that I prefer doing it, the second way. You always multiply just by the reciprocal. Now, just so we're clear, what would have happened if that would have been negative 2/5 A instead of positive 2/5 A? What would we have multiplied by? 5 over 2 again, positive or negative though? So what I'm saying is if we had this problem, negative 2/5 A equals negative 4. I want to get a positive 1, right, in front of the A. So what I multiply by is the reciprocal, but it must also be negative. And the negative sign, you can put it out front or you can put it on the top with the 5. Or with negatives, you can also put it on the bottom. Negative signs are kind of weird. On a fraction, a negative sign can be on the top or on the bottom or out in front. But it can't be on the top and the bottom because then it's positive. So whichever way you do it, put your negative sign on top and bottom. And now when you multiply, what is a negative times a negative going to have to be? Positive. So that'll give you your positive 1. With me? Does that clarify that question? Okay. Okay. You got it? Okay, so if you're comfortable with it. Oh, you turn to a decimal. Okay, decimals are okay. The danger with the decimal is because this decimal is 0.4, right? But if it's something like 2 over 3, then the decimal is like 0.66666, and like where do you stop? So you get into that problem with, like on your calculator, how many decimal points do you go? And then when you do it on the other side, you're going to have some error, some what's called rounding error. So that's the only drawback to the decimal. Okay, what other questions? 47? Okay, so this will be a very, very good exercise to kind of extend on what we just did. Negative 1/5 B equals negative 4/5. And try and write it the way they wrote it. They put the negative out front, right? All right, so this is exactly like I was just saying, right? We have a fraction in front of B. We want to get rid of it. So do y'all like the idea of multiplying both sides by the reciprocal instead of dividing by the fraction? Okay, let's do that then. I'm going to multiply both sides here by what? Negative 5 over 1. And again, the negative, I can put it up on the 5 or down on the 1. Doesn't matter. What I do to one side, I'm going to do the other. Right. Now, just look at the negative signs and don't even worry about them because negative and negative we know will be positive. So we're just going to kind of chunk it at the end. And then that should turn out to be a 1, right, because the 5s will cancel. Or if you multiply straight across, you get 5 over 5. So everything's gone except a 1, which leaves you with the B on the left. On the right side, how do you want to do this? You want to go straight across or you want to cancel the 5? See, that's up to you. There's really no wrong. Just go across. Okay, now again, I know I have a negative times a negative, so I know my answer is going to be positive. And I get 20 on the top and I get 5 when I multiply straight across on the bottom. 20 divided by 5 is 4. So your answer is 4. Any others off this? 49? Okay, yeah, that's an interesting one. It's negative 41 equals negative x. To solve for x, all you have to do is get x by itself, and it can't be negative, right? We want a positive x, or positive 1x. Right now it's a negative, and anytime we see a negative in front, we can always look at a negative as a negative 1. Can't we? Negative sign in front of a variable like that, it's just like a negative 1. So how could you make it a positive 1? You mean move the whole thing over? You could do that. That's one way. But if we're following what we've been doing, we want to divide both sides by whatever number's out front, right? So what's the number in front of x? Negative 1, right? Negative 1. So why don't I divide by negative 1, and then whatever I do one side, divide the other side also by negative 1. What is negative 1 divided by negative 1? Cancel that, and you just get a 1, really, right? So you're just left with x on the right. And on the left, negative divided by negative, positive, and it's just 41 over 1. That's going to be 41. Now, interestingly enough, on this problem, you could have also multiplied both sides by negative 1, and you would have got the same thing. Because, well, I don't want to confuse you. Never mind. Just, we're happy? Is this okay? Yes. 43. I don't mind answering questions because it makes me believe that you made an honest attempt at all this, which is good. Okay, 4/5 equals negative t. That. You could write negative t over 1 as long as you're happy with the fact that what's in front of that t is a 1, actually a negative 1. And then it's very much like the problem we just did. We're trying to make it a positive t. Right now it's a negative 1t. So I can divide both sides by negative 1, right? Divide the right side by negative 1, divide the left side by negative 1. We got that weird looking fraction again, don't we? On the left. What's the right side, though? Take care of that first. It's just 1, which gives us just our t, right? Now, I want you to focus 4/5. What would 4/5 divided by 1 be? What's anything over 1? It's itself, right? So that right there highlighted in yellow, that's just 4/5. What do you think the negative makes it? Negative, right? I mean, so that negative 1, all it's doing is changing the sign. So you could write negative 4/5. Or you could write, that negative can be on top, the negative can be on the bottom or out front, or the negative could be on the bottom. Any of those answers would be okay. Any of these answers, because of the property of negatives on fractions. Okay. I would like to try and move on. We have, I don't know if you've looked at our schedule, but our schedule actually has, for today, we have 2 sections to cover today. Right, so 2 sections. What I'm going to do is I'm actually going to present the material as if it's one section. What happens is in the first section they talk about solving equations, and in the second section we're supposed to do, they add one little twist to it. What I'm going to do is I'm going to throw the twist in the very beginning. You're never even going to know the difference. You're just going to think it's all presented as one topic, okay? Sign-in sheets coming around. All right, so we are going to do right now 2.2 and 2.3. This is solving linear equations. We're just going to call it that, solving linear equations. Now, we've already been doing this, okay? That's what 2.1 was about. But 2.1 was just getting us to understand the 2 basic properties that we can use for equalities. Adding and subtracting anything on both sides, multiplying, dividing both sides by anything, except 0. So that was just to get our feet wet. Now we want to get into a more general, like how do you solve linear equations? And I'm going to have a 6-step process. Okay, so for those people who like steps, we're going to have a 6-step process for this. But before we can begin any of it, we have to understand what a linear equation is. And I'm going to also add one more thing to this that the book doesn't really mention, but because of what's coming later, I think it's important to point it out now. Okay, later, like a couple of weeks from now. Okay, we're going to be solving linear equations in one variable. Later on, I guess the reason why I'm trying to point this out is because later on we will have a section called solving linear equations in 2 variables. And then we're going to change it from linear equations, we're going to change it to linear inequalities in 1 variable, and then we're going to do linear inequalities in 2 variables. So we should start now talking in that language so that we know, kind of as we go forward, we can see the differences. So solving linear equations in 1 variable, we need to first understand what it is. What's a linear equation in 1 variable? So I'm going to define it for you. A linear equation, I'm just going to put EQ, in 1 variable is a mathematical statement with these things. 1, equal sign. You have to have an equal sign. Later on, we will replace an equal sign with something called an inequality. It won't be the same thing. So we have to have an equal sign in order to be talking about a linear equation in 1 variable. We must have, of course, 1 variable. So the common variables are x, y, z, a, b, the things that you've seen in your book and your homework. Okay. So right now, what we have with just those 2 things is an equation in 1 variable. What makes it linear? Okay, that's our next question. What makes it linear? Why do we include that word in there? So this is the big kicker and the last thing that we need. The variable must have as its highest power and if you don't like the word power, you want to use exponent instead. 1. In other words, the number 1. Okay. I'll explain it as I write this down. Okay. I'm going to give you an example right below this. So here's an example. 5x plus 3 times x minus 1 equals 4x minus x minus 7. We'll be able to do that in a little while. Okay, we're going to build up to it a little bit, but that's a problem that we'll face at the end of class today for sure. So let's talk about this and being able to recognize it. Okay, part of math that kind of gets left to the side a lot is the fact that a lot of math is being able to identify the problem before you even begin it. All right, so you need to be able to look at a problem and know what you're working with. And if, like for this, if we have a 6-step process, you need to know that that 6-step process applies. So you got to know it's a linear equation in 1 variable. If it's not a linear equation in 1 variable, we'll have a whole nother set of steps. So let's check this out. We have equal sign, right? There we go. We got equal sign there. We have 1 variable, x, 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 right? And the power or exponent on that variable, the highest it can be is 1. So whenever we don't write a power, anyone need to sign in? Whenever we do not write the power, what power is there? It's a 1. It's what we call implied. It's implied. Kind of like it's implied that we all wear clothes, right? No one has to tell you to wear clothes before you come to school, right? It's implied. Understood. Same thing with an x. Just x by itself, nothing there. It's implied that that's a 1. So I have an implied 1 on all these x's, which gives me my last condition. All right, so as long as we have linear equation in one variable, we will follow a 6-step process to solve them. Now, finding a solution means trying to figure out what x I would plug in, what number could I replace all those x's with to make the statement true. All right, that would be called the solution. So let's go ahead and just start grinding away at this. Oh, wait, hold on, let me give you the steps first. You probably want the steps. Steps. Okay, first step. Now, these steps are in your book. They are on page 122, and then they're also back on 114. What I'm going to do is I'm going to give you the steps on 122, because if I give you the ones on 114, then the ones on 122, they add that wrinkle into it, and I'm going to just give that to you now. So step 1, page 122, is to simplify both sides of the equation. Now, what do we mean by simplify? Well, first off, they say clear parentheses. Clear parentheses. Now, parentheses are used to group things together, right? These are called grouping symbols. Are parentheses the only thing that we use in math to group things together? Have you all seen things other than parentheses before? What have you seen? What else do we like to use? Brackets or braces. I believe this book sticks to the parentheses pretty good, so that's what I'll stick with. So we want to clear parentheses. What this really means is rewrite it where the parentheses aren't there anymore, and that's usually going to require us distributing something through the parentheses. But that'll be the first thing. The second thing, within this step, we're still in step 1, the second thing is to clear fractions and or decimals. So the first thing we're going to do is get rid of any grouping symbols, and then we're going to go ahead and get rid of any fractions or decimals if they are there. They may not be there, but if they are, we'll get rid of them. And then we'll combine all like terms. Now, what are like terms? We'll have to talk about that, but that's important to point out. We want to combine like terms, and I'll define kind of what a like term is in a minute. That's your first of 6 steps. Now, after you've done that, step 2, use addition. I'm just going to put add sub property. To get all variable terms on one side of the equation. So we're gonna get all of our we're gonna add and subtract things on both sides using that property to get all our variable stuff on one side. And it doesn't matter if it's the left side or the right side, it's up to you. But we want to get them all to one side. Anyone know what the next step is? Let me do something real quick. Oh. I'm out of room here. Next step, if we get all the variables to one side, then on our next step, we're going to try and get all the numbers, things that don't have variables, to the other side, the opposite side. So that'll be our third step. So use add subtract again, property, so quiet in here, to get, how do they call it, constant terms, to get all constant terms on the other side of the equation. So constant, just remember constant means just like a number, all the numbers, all the constant terms. We call it constant because numbers stay the same, right? The number 4 is always 4, so it's constant. Variables can change. Fourth step, use the multiplication and division property, okay? So use multiplication, division property to get a 1 in front of variable term. That's very similar to what you did in your homework, right? Trying to get rid of that 2/5 in front of the A or whatever it was. So we want to multiply or divide both sides by something to get that. And then the fifth and final, oh, I said sixth step, I lied. Fifth step is to check your answer. That'll be your answer, whatever you get in part 4. We'll check answer in part 5. Are you ready? We're going to try this. All right, first example. Solve the following. 2 plus 7x minus 5 equals 6 parenthesis x plus 3 plus 2x. You know, sometimes I sit here and I think about all of my students and whatever lives you have, and you know, whatever it is that you've got going on, whatever it is that you're interested in. And I kind of step back and go, it must kind of be hard to sit here and do this sometimes as a student, you know, to really come back and just look at like, what in the world are we doing this for? You know, like, why are we doing this? And, you know, I think since you're all in college, I think we should just address that real quick, because I understand, like, how often do you ever run into this in the real world, right? I mean, do you ever have to do this? Probably not. So let me just give you a real quick opinion of mine. First off, mathematically speaking, what we're doing right now is kind of like if I were to take you outside with a piece of wood, some nails, and a hammer, and you've never used a hammer, never used nails before, and I taught you how to use a hammer to put a nail into a piece of wood, right? It's just a tool used to put a piece of metal into a piece of wood. Why would you want to do that? Maybe you want to build something, right? You want to build a house, whatever it is, right? So I teach you how to use that tool, and then you can go on from there and you can build something. Well, math is the same way. All this is just teaching people how to use hammers, screwdrivers, and then once you get into like calculus, you actually start building stuff. And you start applying this to something. So if you're never going to be in calculus, you're never going to be building anything with math, then why do you need to take it, right? Well, for the same reason I had to take English and World Lit and history and government and all those classes I didn't like when I was in college too. The idea here is really, to me, math at this level is about you demonstrating the ability to follow processes and steps. That's what it's about. Can you take an algorithm like a 5-step process and apply it to something? What that tells me is if you can do that, and you can take art and learn about art, and you can take history and retain that and whatever it is, and you get a degree, a piece of paper at the end, right, that says you've completed a degree, As an employer, someone looking to hire people, what that tells me is that you have a broad education. You've demonstrated the ability to learn. That makes sense? I mean, I know you're teachable, so I'm not going to hire you and you're going to be like, huh? No, just do this. What? I mean, you're gonna be able to do it, right? So that's part of what this is about. So whenever you're sitting here just scratching your head, what in the hell are we doing this for? Just kind of keep that all in mind, all right? All right, but let's get to the process. First thing is not the first step. You can't do the first step until you know what you're looking at, right? Is this a linear equation in one variable? Yes. Okay, I'm not going to highlight everything, but it is. Equation, one variable, all of them to the first power. Okay, since it is a linear equation, one variable, I will follow the steps. My first step is to do what? Remove parentheses. Okay, remove parentheses. So I have one set of parentheses here. I have an x plus x plus 3 trapped inside of the parentheses. So the only way to get that out is to take care of it by multiplying whatever number is in front of the parentheses through the parentheses. They call that distributive property, right? Distributive property of multiplication through addition or over addition. I'm being technical, but that's what it's called. So I'm going to take that 6 and do what with it? Multiply it times the x, and then I'm going to take that 6 and multiply it times the 3. When I do that, I can rewrite the whole thing, and I can not have those parentheses anymore. Now, don't be worried about, paper, wasting paper. What you want to get good at is writing math that makes sense. So I'm going to rewrite the entire line again, everything. 2 plus 7x minus 5 equals, now my multiplication. 6 times x was what? 6x. And then what's 6 times positive 3? 18. So I do plus 18, positive 18, so plus 18. And then what was still hanging out there on the end? Plus 2x. Okay, have I removed all grouping symbols? Yes? Okay, what is the next step? What is it? I forgot. Well, I guess I could just go back one page. There we go. I want to clear parentheses, right? Which I've done. I want to clear fractions and or decimals. So let me go back there. Did I have any fractions or decimals? No. So nope, no fractions or decimals. I jumped the gun there. I'm not on part 2 yet. Okay, next thing, combine like terms. Combine like terms. So I'm going to go back over here. And on the left side of the equation, I'm going to look at everything over there. And I'm going to combine together whatever can be combined. So what can be combined over there? The 2 and the minus 5, right? The 7x is a variable term. The 2 and the negative 5 are constant terms. So you can put constants together, you can put variables together, but you can't put constants and variables together, right? So I'm going to take the 2 and subtract 5. What's 2 minus 5? Negative 3. Now what do I do with the 7x? Just leave it, right? Okay, so 7x, and then behind it I can put minus 3. Now, you could have also done it this way, all right? This would not be wrong. Put or underneath this, but I'm going to erase this after I'm done. You could have done this, okay? Either way would work. You can have 7x take away 3, or you can say negative 3 plus 7x. Either way. But I'll stick with this one here. Now, what's going to happen on the other side of the equation? Do we have any like terms here? We can combine the 6x with the 2x, right? And we're adding them, so 8x, right? 8x, and then what about the 18? Plus 18. Okay. Have we combined like terms on both sides? Yes. All right. Step 1 is now done. Step 2, I'm going to go back and look at step 2. Use addition or subtraction property to get all variable terms on one side of the equation. So what I'm allowed to do right now is add and subtract whatever I need to so that all my variables are on one side. So I'm going to highlight the variables. I've got 8x on the right. I've got 7x on the left. I need those to all be on one side. So what I'm going to choose to do is subtract or add some number of x's from both sides. What would you like to do? There's not a wrong way to do it. I mean, you can do it either way. You can minus 7x on both sides, or you can minus 8x on both sides. It does not matter. Sometimes a little easier one way than the other, but subtracting 7x is the way I think I'll go because it's the first thing I heard. And what happens if you subtract 7x on the left? What happens? Goes away, right? On the right, when you take away 7x from 8x, how much are you going to have left over? 1x, which is ultimately what we want, right? 1x. Okay, so that's what I'm choosing to do. Now I'm going to do this doing the vertical addition and subtraction. I'm going to come in here. I'm going to subtract 7x here. I'm going to subtract 7x here. And then I'll even put the line underneath like this. And left side is gone. All that's left on the left is what? -3. Don't forget your equal sign. 8x, we said take away 7x was x. And then we still have plus 18. All right. We are done with the second step, right? We've got our variable terms on one side. X's are on the right. Next step, use the addition subtraction property to get all constant terms on the other side of the equation, opposite of your variable. So my variable's on the right, so that forces me to get all my constants to the left. That means the only constant on the right, positive 18, needs to get out of there. So to get rid of a positive 18, we subtract 18. So I will subtract 18 on both sides. Here's my line. I've seen students write, they draw a line, they go all the way across. Just be careful with that. I like to do a line that's separated because there's that equal sign there. So it helps me remember to put the equal. Okay, what do I get on the left side? What's -3 take away 18? -21. Now, this is going to depend on you, how comfortable you are with that, -21. What I would be a little weary of is if you did that, -3 minus 18, you had to have your calculator to do that. That's a warning flag that you're not comfortable with integers, and really to the point that it's going to be a bit of a struggle in this class if integer addition and subtraction is still got you, you know? So if you have trouble with that, I think you need to make a note of it, come by and see me, or go to the tutoring lab, say, I need help with addition and subtraction of signed numbers. I'm just still confused on it, all right? On the right side, 18's cancel, and we have x. So I've done step 3 now, right? I have all my constants on one side, all my variables on the other. Now, we actually are done, aren't we? But let's see if all the steps are complete here. The fourth step is to use multiplication division property to get a 1 in front of the variable term. Well, I already have a 1, don't I? I have a 1 in front of x. And that's just how nice that problem was. So I'm just going to put a check. 4 is done. The last step is step 5, is to check your answer. So step 5, I'm going to check. How do you check a solution? You take that answer that you think x is, -21, and you plug it into the original problem, way up at the top. So what I'm going to do, because I'm kind of stuck on a piece of paper here, I'm going to just force there to be space in here, okay? And I'm going to plug it in right there, all right? So what I'll do is everywhere I see an x, I replace it with what? -21, so I'll do it in red, -21. And notice I put it in parentheses. Why do you think I put it in parentheses like that? Because I'm multiplying 7 times x. If I hadn't put the parentheses, you might think that that's 7 minus 21, right? Maybe? I don't know. And then I have -5 equals 6 parentheses. Now here, do I need -21 in parentheses? No, because it's already in parentheses, and all I'm going to do to it is add 3, and then plus 2, and now it is multiplication, so I'll put it in parentheses, -21. My My job here is to make sure that whatever this turns out to be is a true statement. So is it correct? So on the left side, what's the order of operations? What's the order of operations? Parentheses, exponents, multiplication, division from left to right. So I'm going to do that multiplication first. What's 7 times negative 21? 147 minus 5. On the right side, 6. I'm going to do what's in parentheses first. What's negative 21 plus 3? Negative 18, right? I'm going to go ahead and do the multiplication at the end. What's 2 times negative 21? Negative 42. I might have pushed my pen. No, I'm okay. All right, let's do the left side. What's 2 take away 147? Negative 145. Take away 5 more. Negative 150. On the right, what's 6 times negative 118? And maybe you need your calculator. That's okay if you do. It's 60 plus, it's negative 108. It's negative 108. And then take away 42 from that, and what do you get? Negative 150. So is negative 150 equal negative 150? As far as I know, it's correct. So that checks. Okay? Now, I mean, I definitely need to give you some examples to work in class because I need to go around and like see where everyone is. All right, just kind of see where your skill level is. But before I do that, I want to at least give you something that's a little more involved that has maybe some fractions in it, so at least you can see how to do one of those. All right, here's a good one. How about solve 1/3 x plus 7 equal, no, not equal, sorry, minus 1/2 x plus 1 equals 4. So after this example, I'll give you 2 to work in class, all right? I will try as much as I can to let you work in class because watching me is one thing, doing it on your own is a different thing. But like I said, with the amount of material we have, we may be limited to how much like hands-on group work we're going to be able to do in here. But at least to start the semester, I want to at least know where you are. All right, so everyone looks at that. First, it's a linear equation, one variable, right? Linear equation, one variable. Got that so far. Step 1 is what? Grouping symbols. Okay? You've got to clear the grouping symbols first. That means no more parentheses. So I have 2 sets of parentheses, one on the left, one on the right. Now, if we follow the order of things, we've got to distribute those numbers through first before we try and clear any fractions or do anything like that. So I'm going to multiply that 1/3 through the parentheses, and that should give me 2 new numbers, or 2 new expressions here. What's 1/3 times x? 1/3 x, right? All right, what's 1/3 times 7? I'll do that on the side over here in green. What's 1/3? I'm going times a positive 7. That's the same as 1/3 times 7 over 1, right? And then multiply straight across, that's what? 7 over 3, or 7/3. So is it plus or minus? Plus. Plus 7 over 3. All right. Did I say we had parentheses on the left and the right? I meant to say they're both on the left. I don't know why I said they were one on the left and one on the right. We have 2 sets of parentheses on the left. All right, what now? Get rid of the second set of parentheses, so I have to multiply what thing through here? -1/2. Okay, you have to take into account the sign in front of it. So what is -1/2 times x? -1/2 x By the way, you cannot be going to decimals on your calculator here, all right? This is a great example of how, 1/3 is like 0.33333 forever, so it kind of messes everything up. Keep everything as fractions. All right, what's negative 1/2 times positive 1? Well, anything times 1 is itself, isn't it? So we should just get negative 1/2. All right, negative times a positive is negative. Now my equal sign, and then 4. Okay, I have now cleared all my grouping symbols out, right? The next step after clearing your grouping symbols was to do what? Clear fractions. Oh, shit. Right? We look at that, we're not happy about it, right? Fractions suck. We've kind of come to terms with that already, right? So how do we clear fractions? And there's a set of steps. This is the first time we've seen this. So there's actually a set of steps now on how to clear fractions. The first thing that we do to clear a fraction, whenever we're working with equations like this, is find what's called the LCD. LCD stands for lowest or least common denominator. So what we need to do is look at all the denominators. Okay, let's look at all the denominators. I'm going to highlight all the denominators. 3, 3, 2, 2. Does 4 have a denominator? That 4 on the other side, does it have a denominator? It's over 1, right? We never consider 1 when we're talking about LCD. Okay, so we don't even have to worry about it. It's only if it's numbers other than 1. So what we do is we look at those numbers. Really, I only have 2 numbers, right? 3 and 2. And what I'm going to do is I'm going to make a list. I'm going to say 2, and here's 3. I'm going to make kind of like a table. And I'm going to list out all the multiples of each one of those. Y'all know what multiples are? Let's focus on 2 first. 2 is 2 times 1, right? What's 2 times 2? Okay, so I'm going to put a 4. What's 2 times 3? 6. 2 times 4? 8. 10. I could go until the end of my life, right, and die and still not be done. It would keep going, wouldn't it? But I'm going to stop about there. And then on the other one, 3, I'm going to do the same thing. That's 3 times 1. What's 3 times 2? 6. 3 times 3? 9. 3 times 4? 12. Keep going, right? What we're looking for when you say LCD is you're looking for the smallest number, the least number that appears on both of those lists. So what's the smallest number that's on both lists? 6. That's your LCD. Okay? The smallest number that appears on both lists. Now, for those of you who may have come from another class, there's like 100 different ways to teach how to find LCDs, right? Some of them you do like a factor tree, and then you write all the factors, and you say, it can get really complicated. This, to me, is the cleanest, quickest way, as long as you can come up with the multiples. Now, let me point this out also. What if, okay, what if, and this is an if, what if I had another denominator other than 2 and 3? What if I had 2, 3, and 4 also? So I'm going to just throw it in here. What if I would have had a 4 also? I would have had 8, all the multiples of 4, right? 8, 12, 16, right? And then my LCD would not have been 6, would it? It actually would have been 12. See, the 2 column doesn't have a 12, but I would have had 12, 12, 12, so my LCD would have been 12. If you have 4 numbers, then you have to get all 4 columns to match up. So it's just, it just depends on the problem. I don't think you'll have more than like 3, hopefully. I haven't looked at all the homework, but. All right, so we found our LCD, right? That's the first thing. After you find your LCD, here's what you do. You multiply both sides of equation by the LCD. That's our second step here. Multiply both sides by the LCD. Now, our LCD here is 6, isn't it? So watch what I'm going to do and try and get this all to fit here. I'm going to take my original problem, or not my original, the one that I have right up there is 1/3 x plus 7/3 minus 1/2 x minus 1/2 equals, I'm going to leave a little space here and put a 4. Okay, that's just the problem I had up above, right? I'm going to multiply both sides by 6. So what I need to do is I need to put the entire left side in parentheses and put a 6 out front. Now on the right side, I need to multiply by 6 also. So I'm put a 6 out in front of the 4. That's why I left a space. And it's just times 4. I do not need parentheses. Why? On the right side. It's just a single term, right? 6 times 4, boom, done. If it was a couple of terms on the right side, I would have to have parentheses that I have to distribute through. All right, fun with fractions now. We get to distribute that 6 through. That 6 will multiply times 4 terms like this. So what is 6 times 1/3? 2. 6 times 1/3 is the same as 6 over 1 times 1/3, which is 6 over 3, which is 2, right? I'm going to show that on the first, well, I'll do it on the first 2, but I won't do it after that. Is that all right? 6 times 1/3 is 2, so 6 times 1/3 x is 2x. With me? What about 6 times 7/3? 6 over 1 times 7 over 3 is 42 over 3, which is what? 14. Plus or minus? Plus 14. What's 6 times negative 1/2 x? So what's half of 6? 3, but negative, right? So negative 3x, and then the last multiplication, 6 times negative 1/2 is negative 3, and then equals on the right side, 24. What we've done is we've taken something with fractions and we've rewritten it as something without fractions, which is nice. All right, we're still in step 1 here. We've got rid of our grouping terms. We've cleared fractions. And so now what we need to do is make sure there's no decimals, right? There's no decimals here. Collect like terms is the next step. So my like terms on the left are highlighted there in yellow and blue, right? I can put the x's together. I can put the numbers together. So what's 2x take away 3x? Negative 1x or just negative x, right? Either way. And then what's 14 take away 3? Plus 11 equals, the right side is 24. So I have now collected like terms. Step 1 is officially complete. Step 2? What's that? Yeah, we're going to have to try and get our variable term by itself on one side. But I only have x's on the left, right? So if I just got rid of that 11 over there, we'd be good. So we're going to subtract 11 on both sides. Does that seem okay to you? What still remains on the left side? Negative x. What remains on the right? 13. Step 2 is done. What's step 3? We need to get all the constants on the other side, right? Oh, wait, hold on. That was step 3. Our variable was, well, hold on. Step 2 and 3 kind of happened at one time, didn't it? We got the variable by itself, step 2, but in that process, our constant is now by itself on the other side. So step 2 and 3 kind of happened all together, which is nice. What's step 4? Divide both sides by negative 1. Right? We don't like that negative 1 in front. So I divide by negative 1, divide by negative 1. Negative 1 over negative 1 is 1, so we get x on the left. On the right, what do we get? Negative 13. Step 5 is to check. I'm not going to because you need to do some problems, okay? So here's what I'm doing. I'm going to give you 2 problems to do. I'll kick the lights on in a second. We'll see how you do with it. What we're going to do is we're going to make this your first quiz. If you can work together, okay? You can use your notes, you can use your book, you can ask for help, okay? But let's take it as a first quiz grade, mostly because what I want to do is I want to be able to collect it, and I want to be able to see where you are. Just kind of like see what your handwriting looks like, everything, so I know a little bit more about you. If you don't finish it today, it's okay, but let's try and finish it before you leave. Both of them are going to be fraction problems. You're welcome. So on your paper, what I want you to do on your sheet of paper that you're going to turn in, just make sure your name and date are somewhere on the top, and make sure it's legible. And yeah, it will be separate, so you don't be writing on the back of your notes. Everyone good with that? Go ahead and get started. Below this, I'm going to put your homework assignment, okay? So give me a second to figure out what problems I'm going to assign. Y'all get working on that. You got about, what, 20 minutes? 10 minutes a problem? Make a friend. Maybe someone at your table is really nice. Maybe they're real weird. I don't know. Anybody come in late that needs to sign in? Yes. You weren't on the list? Okay, are you on? You're not on here now? No, just add your name to the bottom here. And then make sure, check with, go into the system. Okay, you're in there? Okay. Most likely I won't change it here. I'll just stick with this. So sign in for Monday also. Oh, you weren't here Monday? Okay, well then sign in for today. Yeah, just initial. And do you know how to get into Canvas? Okay. Okay, all right, very good. Oh yeah, that's right, I'm sorry. Okay, I've put your homework assignment up here. The 2 problems at the end that I've highlighted are problems that we really didn't get to talk about. So when you try them, you'll see something crazy is going to happen, and we'll address that first thing class next time. But at least try through 25.